Keeping up with our motto that learning be a joy and teaching a pleasure, here we are with the remote teaching and learning process to bridge the gap. Happy learning, students! Today we are going to start with Class 9 Science, Chapter number 3, Current Electricity. Topics which I am going to cover during this session are Introduction to Electricity, Potential Difference, and Current flowing through a wire. Electricity is of utmost importance in the modern world. We depend on it for almost everything in our day-to-day life. Electricity is used to run different types of motors, cars, drill machine, and various appliances. It is also used to run different communicating devices like computers, portable phones, radio, and television. It is also used to run several domestic appliances like oven, iron, refrigerator, air conditioners, then light, lamps, flashlights, etc. The lightning that strikes the earth is an excellent example of natural flow of electricity. What is electricity? Electricity is a form of energy that can be easily changed to many other forms. In simple words, I can say electricity is the result from the flow of electrons, as you can see over here in the picture. When the electrons are moving, you can say there is an electricity. It results from the flow of electrons only. What is an electric current? An electric current is the rate of flow of electric charges in a circuit. As shown in the picture, bulb with the help of the connecting wire is connected to the two terminals of a cell. So, there is a flow of electron from the negative terminal to the positive terminal, which results in an electric current, and the rate of the flow of electric charges in the circuit is nothing but the electric current. Now, in order to understand that how this electricity is flowing in a circuit, we need to understand what is potential difference. To understand potential difference, let us take this example. Here you can see there are two tanks, tank A and tank B. In first case, water is exact the same level in both tanks. So water won't flow from one tank to another tank. But in the second case, you can see tank A has higher water level. So the water will flow from tank A to tank B. This is according to diffusion. Right? Do you remember diffusion? The flow from the higher concentration to the lower concentration. So the water will flow from tank A to tank B. Similarly, electric charges will flow from a point of a higher potential to the point of lower potential. Just like water, the flow of electric charge between the 2 points, it depends on a kind of electric level at those points. This level is called electric potential. Over here you can see in this picture the two terminals of the battery. One is positively charged and the other is negatively charged. So this positive terminal is at the higher potential as compared to the negative terminal. So this difference in the electric potential between the 2 points in a circuit is known as potential difference. It is the same as voltage also. A positive charge flow from a point of higher potential to the point of lower potential. We have seen earlier that the electricity flows due to the conduction of negatively charged electrons. Electrons flow from the point of lower potential to the point of higher potential. In your 7th class, you have learned that a lightning strike is the flow of electrons from the point of lower potential on the clouds to the point of higher potential on the earth. As shown in the circuit, the particles that carry the electric charge through the wire in the circuit are the mobile electrons. They are moving from negative terminal to the positive terminal. The electric field direction within the circuit is, by definition, the direction that positive test charges are pushed, and thus negatively charged electrons, they move in the direction opposite to that of the electric field. Here you can see the flow of electron is from negative terminal to the positive terminal, but the direction of current is from positive to negative. In other words, I can say that the flow of positive charge determines the direction of electric current. Since like charges, they repel and unlike attracts, right? So positive charge is repelled from the positive terminal and it is moving towards the negative terminal, whereas the negatively charged electrons are getting attracted towards the positive terminal. So they are moving from negative to positive terminal. And that's why the current flows from positive to negative, because of the direction of the flow of protons, that is positively charged protons. Potential difference. The difference in potential between the positive and negative terminals of the cell is called the potential difference of that cell. Now this potential difference is caused by the chemical reaction occurring inside the cell. The potential difference sets the electrons in motion and results in the flow of electricity through the conducting wire connected to the two ends of the cell. So, the amount of work done in bringing a unit positive charge from one point to another point in an electric field is called the potential difference between the 2 points. As per the definition, we can get the formula of potential difference as work done upon charge, total charge that is transferred. So, V indicates the potential difference, W is work done and Q is the charge that is transferred. So, W is equals to VQ. Potential difference is a scalar quantity. The SI unit is joules per coulomb or volts. It is responsible for the flow of electric current in the conductor, and it is measured by a device called voltmeter. Now, let us understand that how electric current flows through a wire. As shown in the figure, if a connecting wire, that is a copper wire here in this case, is not connected to a cell, then its free electrons, they will move randomly in all the direction in the space between the atoms. Here, white color circle, they show the atoms, and the green color circles which are moving, they represent electrons. So, when this copper wire is not connected to the cell, in that case, the electrons, they are randomly moving in the space around atoms. Now let us see what will happen if we connect the two ends of the wire to the two terminals of the cell. Now, here in this picture, the first part shows the electrons, they are not moving in any particular direction. That means they are randomly moving. So in that case, there is no electric current. But when we connect the two ends of the wire to the two terminals of the cell, electric force acts on the electron, and being negatively charged, they start moving from the negative terminal to the positive terminal. That means the terminal with the lower potential to the terminal with higher potential. Due to the flow of these electrons, the electric current starts to flow through the wire. Here you can see the copper wire is not connected to a battery. So the ends A and B are at the same electric potential. Hence, there is no electric current that is flowing through this wire. But here in this case, the wire is connected to a battery. So A is at the higher electric potential than B. Therefore, the current will flow from point A to point B. This is all for this session. Thank you so much.